In this class, we are going to look about farm trusses and also king and queen posts. Farm trusses. It can be seen from a stress distribution of a load beam that the greatest stress occurs at the top and bottom extremes of the beam. Well, this led to the improvement of a rectangular section by introduction of one section in which large flanges were situated at a distance from the neutral axis. In effect, the flanges carried the bending in the form of tension stress in one flange and compression stress in the another, while the shear was carried by the web. For this situation where bending is high but shear is low, for example, in a roof design, material can be saved by raising a framework design. A truss is a pinpointed framework, and a truss concentrates the maximum amount of materials as far away as possible from the neutral axis, with the resulting greater momentum arm, which is denoted by letter H. Much larger moments can be resisted, and resistance of a truss at a section is provided by an equation M is equal to C into H, which is equal to T into H, that is, where C is equal to T in parallel chord and C is the compression in the top chord of the truss, and T is the tension in bottom chord of a simply supported truss, and H is the vertical height of truss section. If either C, T or H can be increased, then the truss will be capable of resisting heavier load. The value of H can be increased by making a deeper truss. Allowable C or T stresses can be increased by choosing a larger cross section of the chords of the truss or by changing to a stronger material. A framework of truss can be considered as a beam with the major part of the web removed. This is possible where bending stresses are more significant than shear stresses. The simple beam has a constant section along its length, yet the bending and shear stresses vary. The truss, made up of number of simple members, can be fabricated to take into account its change in the stress along its length. The pitched roof truss is the best example of this. Although the original shape was probably designed to shed rainwater, roof trusses consist of sloping rafters, which meant at the ridge a main tie connecting the feet of the rafters and internal bracing members. They are used to support a roof covering in conjunction with purling, which are members laid longitudinally across the rafters, the roof covering being attached to the purling. The arrangement of internal bracing depends on the span. Rafters are normally divided into equal length, and ideally the purlins are supported at the joints so that the rafters are only subjected to axial force. This is not always practicable, since purlin spacing is depending on the type of roof covering. When purlins are not supported at the plane joints, the rafter members must be designed for bending as well as axial load. The internal bracing members of truss should be triangulated and, as far as possible, be arranged so that long members are in tension and compression members are short to avoid buckling problems. The outlines forms for various spans. The thickness lines indicate trusses. Steel and timber trusses are usually designed assuming pin-jointed members. In practice, timber trusses are assembled with bolts, nails or special connectors, and steel trusses are bolted, riveted or welded. Although these rigid joints impose secondary stresses it is seldomly necessary to consider them in the design procedure. The following steps should be considered when designing a truss. First is select general layout of truss member and truss spacing. Second is estimate external loads to be applied including shelf weight of the truss, purlins and roof covering together with wind loads. Third is determine critical, which is worst loading. It is usually considered dead loads alone and then dead and imposed loads combined. Fourth is analyze framework to find forces in all members. Fifth is select material and section to produce in each member a stress value which does not exceed the permissible value. Particular care must be taken with compression members or members normally in tension but subjected to stress reversal due to wind uplift. Unless there are particular constructional requirements, roof trusses should as far as possible be spaced to achieve a minimum weight and economy of material used in the total roof structure. As the distance between the trusses is increased, the weight of purlin tends to increase more rapidly than that of a trusses. For spans up to about 20 meters, the spacing of steel trusses is likely to be about 4 meters, and in case of timber, it is 2 meters. The pitch or slope of a roof depends on locality, imposed loading, and type of covering. Heavy rainfall may require steep slopes for rapid drainage. A slope of 22 degree is common for corrugated steel and asbestos roofing sheet. Manufacturing of roofing material usually makes recommendation regarding suitable slopes and fixings. Now we'll look at frames. Apart from the roof trusses, there are a number of other structural frames commonly used in farm building construction. They include portable frames, pole barns, and post and beam frames. A single way portal frame consists of a horizontal beam or pitched rafters joined rigidly to vertical shanklings on either side or to form a continuous plane frame. For the purpose of design, portal frames can be classified into three types, which is fixed base, pinned base, and pin based and rigid. The rigid joints and fixed base have to withstand bending moments, and all bases are subject to horizontal as well as vertical reactions. Hence, foundation design requires special attention. The externally applied loads cause bending moments, shear forces, and axial forces in the frame. Portal frames are statically indeterminate structures, and the complexity of the analysis precludes coverage here. However, the results of such calculation for a number of standard case of loading are tabulated in handbooks. Using these and the principle of superposition, the designers can determine the structural section required for the frame. Determining the maximum value of bending moment, shear force, and axial force acting anywhere in the frame allows the selection of adequate section for use throughout the frame. Care must be exercised to ensure that all joints and connections are adequate. Portal frames may be made up of steel, reinforced concrete, or timber. With wider spans, the structural components become massive if timber or reinforced concrete is used. Hence, steel frames are most common for spans over 20 meters. At the eaves where maximum bending moments occur, the sections used will need a greater depth than at other points in the frame. Now we'll look at butt joints. The use of guts permits member to butt against each other in the same plane, avoids eccentric loading on the joint, and provide where necessary greater joining area than is possible with lapped members. This is often an important factor in nailed and glued joints. Arrangement of members on a single center line is usually possible with guts. When full-length timber is not available for a member, a butt joint with cover plane can be used to join two pieces together. This should be avoided if possible for the top members, that is rafters of a truss, and position near midspan for the bottom member. Bolt and connector joints. Simple bolted joints should only be used for lightly loaded joints, since the bearing area and the hole diameter times member thickness and the relatively low bearing stress allowed for the timber compared with the of the steel bolt may cause the timber hole to elongate and fail. Timber connectors are metal rings or toothed plate used to increase the efficiency of bolted joints. They are embedded half into each of the adjoint members and commonly used for light structures. This type of commonly used light structures is the toothed plate connector, or a mild steel plate cut and stamped to form a triangular projecting on each side and embedded in the surface of the members. Upon tightening the bolt which passes through the joint, the double-sided toothed connector transmits the load and the bolt is assumed to take no load. Glued joints. Glue made from synthetic resins produced from most efficient form a joint as strong as or even stronger than that of timber. Joint and may are immune to attack from dampness and decay. With this type of joint, all contact surface must be planed smooth and the necessary pressure providing during the setting of the glue. Bolts or nuts which act as clamps are often used and left in place. The members may be glued directly to each other using lapped joints, or single thickness construction may be used by adopting of gussets. As with nail joints, lapped members may not provide sufficient gluing area, and guts must then be used to provide the extra area. Glued joints are more often used when trusses are prefabricated because control over temperature, joint fit and clamping pressure is essential. For home use, glue is of the use together with nail joints. Nail joints. Joining by nails is the least efficient of these three methods which were explained earlier, but it is an inexpensive and simple method and can be improved upon by using glue in combination with the nails. When trusses are prefabricated in factories, nailing planes are often used to connect the members. These fastens come into two types. First is a thin gauge plate called a pierced plate fastener, which has holes punched regularly over its surface to receive nails. The pierced plate can also be used for on-site fabrication. And second is that a heavier plate with teeth punches from the plate and bent upon up 90 degrees, called a tooth plate fastener or connector. The type in which the teeth are an integral part of the plate must be driven in by a hydraulic press or roller. Now we will look at king post. King post is a central vertical post used in architectural or bridge design, working in tension to support a beam below from a truss apex above. That is where a crown post through visually similar supports items above the beam below. Now let us take a look at a king post schematic diagram. In the schematic diagram of a king post, we are seeing the king post, which is a central vertical post used in the construction of a roofing material. Now we can see the purlin sheet here and the purlin ridge board rafter and principal rafter here, and the tie beam which supports the king post here. A king post extends vertically from a cross beam to the apex of a triangular truss. The king post itself in tension connects the apex of the truss with its base, holding up the tie beam at the base of the truss. The post can be replaced with an iron rod called a king rod, and thus the king rod truss is the name given to that. And the king post truss is also called as Latin truss. In traditional timber framing, a crown post looks similar to a king post, but it is very different structurally. Whereas king post is in tension, usually supporting the tie beam as a truss, the crown post is supported by the tie beam is in compression. The crown post rises to a crown plate immediately below and supporting collar beams. It does not rise to the apex like a king post. Historically, a crown post was called a king post in the regions of England, but its usage is absolute. We can see here in the diagram that the king post is being supported by the tie beam, and king post supports the ridge pole and common purlin over here. King post truss is used for simple roof trusses and short span bridges. It is simple form of truss in that it is constructed of the fewest number of truss members, which is individual length of wood or metal. The truss consists of two diagonal members that meet at the apex of the truss, one horizontal beam that serves to tie the bottom end of the diagonals together, and the king post which connects the apex to the horizontal beam below. For a roof truss, the diagonal members are called rafters, and the horizontal member may serve as ceiling joints. A bridge would require two king post trusses with the driving surface between them. A roof usually uses many side-by-side trusses depending on the size of the structure. Now we'll take a look at queen post. A queen post is a tension member in a truss that can span longer openings than a king post truss. A king post uses one central supporting post, whereas the queen post truss uses two. Even though it is a tension member rather than a compression member, they are commonly still called a post. A queen post is often confused with a queen strut, one of two compression members in roof framing, which do not form a truss in the engineering sense. Like in the king post, we can see that the king post is been subjected to compression force here, but this is a schematic diagram of a queen post. We can clearly see here that it is been subjected to vertical pressure, subjected to only it is just a tension member, but not any compression is not acting on here. You can see the queen post here upon where steering beam is supported by connected on the two posts in the queen post, and it supports the common rafters and ridge beams here. A queen post bridge has two uprights placed about 1/3 of the way from each end of the trusses. You can see two queen posts which are placed at on either sides. They are connected across by the top by a beam and use a diagonal brace between outer edges. The central square between two vertical is either unbraced or has one or two diagonal braces for rigidity. A single diagonal reaches between opposite corners. Two diagonal braces may either reach from the bottom of each upright post to the center of the upper beam, or form a corner to corner, and also in the form of X shaped inside the square. In this diagram, we can see king post comparison between king post and queen post clearly. Here king post is has withstanding the compression force here, and the queen post just has the tensional force here, and we have a principal the queen post supports the principal rafter, and usually there will be two posts to form queen post trusses type, and in case of king post truss, only one single king post will be supporting the principal rafter. Thank you.